So today we discuss GATE Mechanical Engineering 2022 Set 2 paper, and this is the 1 mark question analysis, and this is useful for Opsc Motor Vehicle Inspector. So the first question is, which one of the following is the definition of ultimate tensile strength UTS obtained from stress strain test on a metal specimen? So options are stress value where the stress strain curve transition from elastic to plastic behavior. Option B, the maximum load attained divided by original cross-section area. And option C, the maximum load attained divided by corresponding instantaneous cross-sectional area. And option D, stress where the specimen fracture. So the right answer will be the maximum load attained divided by the corresponding instantaneous cross-sectional area. So option C is the correct answer for ultimate tensile strength definition. Next question. A structural member under loading has uniform state of plane stress, which usually notated is given by sigma s is equal to 3p, sigma y is equal to minus 2p, and tau xy is equal to root 2p, where p greater than 0. The yield strength of the material is 350 megapascal. If the member is designed using maximum dissolution energy theory, then the value P at which yield start according to maximum dissolution energy theory. So these are the options 70, 90, and 120 and 75 megapascal. So we have to solve this according to dissolution energy theory or Von-Mises theory. So given data, sigma x, which is equal to 3p, and sigma y is equal to minus 2p, given minus 2p, and tau xy is equal to root 2 times p, and our maximum the yield strength, which is equal to sigma yt equal to 350 megapascal. So according to dissolution energy theorem, root over of sigma x square minus sigma xy x and sigma y plus sigma y square plus 3 tau xy square, which is equal to sigma yt divided by factor safety. As factor safety is not given, so let us take it is 1. So putting the value, all the value, we get sigma x is equal to 3p times square minus sigma x into sigma y. Sigma x is 3p and sigma y is equal to minus 2p. So 3p into minus 2p plus sigma y is minus 2p whole square plus 3 times of tau xy root 2 times of p whole square, then root over of p is equal to 350 divided by 1. So p common, let us take p common. So root over of p square is p, and root over of 3 square minus 3 into minus 2 plus minus 2 times of square plus 3 into root over of 2 square, which is equal to 350. So p is equal to 350 divided by root over of 3 square is 9 and 3 into 2 6 plus 6 plus 4, 3 into 2, 6, which is equal to 350 divided by 9 plus 6, 15, 15 plus 19, 19 plus 6, 25, and root over 25 is 5, which is equal to 70 megapascal. So option A is correct answer. You have to remember this formula for maximum distortion edge theory: sigma x square minus sigma x sigma y plus sigma y square plus 3 tau xy square whole root over is less than or equal to sigma yt divided by factor of safety. So the answer will be 70 megapascal. Next question. The fluidity of a molten alloy during sand casting depend on solidification range. The phase diagram of a hypothetical binary alloy of component A and B is shown in the figure with its eutectic composition and temperature. All the lines in this phase diagram include the solidus and liquidus line are straight line. If the binary alloy with 15% weight of B is poured into mold at a pouring temperature 800 degrees centigrade, then the solidification range is. So this is the 15%. We have to find this temperature range. So comparing all are given linear diagram. So this is the triangle one, and next this is the second triangle. Comparing both the triangle, can get the answer. So this is 700 and this is 400, and this is 15% and this is 30%. So this temperature we have to found. Let us name this T star. So this black triangle and this yellow triangle are similar, so we can write 700 minus 400 divided by we have to write linearly. So we have to compare 700 minus T star divided by total triangle 700 by 700 minus 400, which is equal to total is this to this distance is 30 minus 15 divided by 30 minus 0. So we can get this is 15 divided by 30, which is equal to half. So 700 minus T star equal to half times of 700 minus 400 is 300, which is equal to 150. So T star will be 700 minus 150, which is equal to 50 degrees centigrade. So the temperature range is T star minus 400 which is equal to T star is 550 minus 400, which is equal to 150 degrees centigrade. So option D is the correct answer. Next question. Which one of the following cannot impart linear motion in CNC machine? Option A, linear motor. Option B, ball screw. Option C, lead screw. Option D, chain and sprocket. So the right answer will be chain and sprocket. We cannot impart linear motion in CNC machine. So next question. Which one of the following is an intensive property of a thermodynamic system? Options are mass, density, energy, volume. So intensive property is density, which is independent of the extent of the system. So density is the intensive property, and mass, energy, volume are extensive property. That means which depend upon extent or mass of the system. Density it doesn't depend upon mass or extent or size of the system. So density is the intensive property. Next question. Which of the following non-dimensional term is an estimate of Nusselt number? Options are ratio of internal thermal resistance of solid to boundary layer thermal resistance. Options B, ratio of rate at which internal energy is adapted to the rate of conduction heat transfer. Option C, non-dimensional temperature gradient. Option D, non-dimensional velocity gradient multiplied by Prandtl number. So we know this is the plate where boundary layer is formed, and the temperature of the plate is Ts. This is y direction coordinate, and as y is equal to 0. This is the thermal boundary thickness del T, and the temperature is high at the plate and gradually decreasing exponentially. This is the temperature T infinity, free stream temperature. So we know theta star is equal to Ts minus T divided by Ts minus T infinite. So y star is equal to y divided by L. So differentiating it, dy star divided by dy is equal to 1 by L. So the differentiating with respect to y, d theta star with respect to dy is equal to minus dt by dy. We know the Q conduction is equal to Q convection. So the formula is conduction is Kf dt by dy at y is equal to 0, which is equal to Q convection is H into Ts minus T infinity with unit area. So minus Kf into d by dy of, we know the temperature is Ts minus T divided by Ts minus T infinity into H equal to H, taking in the left side. So d theta star divided by dy is equal to H by Kf. Okay, then apply chains rule. D theta star divided by dy star into dy star divided by dy is equal to h by kf. So d theta star divided by dy star, and dy star divided by dy we know from the previous page, which is equal to 1 by L is equal to h by kf. So d theta star divided by dy star is equal to this L will taken on right side, HL by kf, which is equal to Nusselt number. So the Nusselt number is d theta star divided by dy, which is a non-dimensional temperature gradient. This is the temperature gradient. So answer will be non-dimensional temperature gradient. Option C is the correct answer. Next question. An electric car manufacturer underestimate the January sale of car by 20 unit, while the actual sale was 120 unit. If the manufacturer uses exponential smoothing method with a smoothing constant alpha is equal to 0.2, then the sale forecast for the month of February of the same year is dash unit. So the actual sale in January, which is the D January, is equal to 120 unit. So the underestimate in January is equal to D January minus D sorry D January which minus forecast of January, which is equal to given 20 unit. So alpha value given 0.2. So forecast we have to found forecast of the February, which is equal to forecast of January plus alpha times D January minus forecast of January. So forecast of January, which is equal to 100 unit, which is equal to 120 minus 20 is equal to 100. So alpha is 0.2 and demand in January, the actual sale is 120 minus forecast in January is 100. So which is equal to 100 plus 0.2 into 20, which is equal to 100 plus 4, which is equal to 104 unit. Option B is the correct answer. Next, the demand of a certain part is 1000 parts per year and its cost is 1000 rupees per part. The order are placed on the economical order quantity EOQ. The cost of ordering is 100 rupees per order and the lead time of receiving the order is 5 days. If the holding cost is 20 rupees per part per year, the inventory level for placing the order is round up to nearest integer. So given data, demand is 1000 unit and the lead time is 5 days, and Rate of consumption D is, we know, demand divided by 365 days per year we have to found, and the reorder level, we know, rate of consumption D into lead time, which is equal to D divided by 365 into lead time, and D given 1000 divided by 365 and lead time is 5, so we get 13.69, which is equal to 14. So the reorder level is 14 unit. Next question. Consider 1 kg of an ideal gas at 1 bar and 300 Kelvin contained in a rigid and perfectly insulated container. The specific heat of a gas at constant volume Cv is equal to 750 joule per kg Kelvin. Exterior perform 225 kilojoule of work on the gas. Assume that the container does not participate in the thermodynamic interaction. The final pressure of the gas will. So given data, mass is 1 kg and pressure P1 is 1 bar and temperature T1 is 300 Kelvin. So this is the perfectly insulated and ideal gas are given at constant volume. That means constant volume, this means rigid container, and ideal gas, the gas is ideal gas and perfectly insulated. So let us draw the container system where a stirrer perform 225 kilojoule work, that is work done on the system. This is stirrer and this is the perfectly insulated container having constant volume. That means change in volume is equal to 0. Insulated, that means heat transfer is 0. So work done in expansion, volume is 0, so it is 0. And given Cv constant volume specific is 750 joule per kg Kelvin, that is equal to 0.75 kilojoule per kg Kelvin. So work done by the system, that work done on the system by stirrer is equal to by 225, stay positive, 225 kilojoule, which is negative work, and we have to found the final pressure P2, and total work done is work done on expansion plus work done on stirrer. Work done in expansion is 0 and work done on stirrer is the total work, which is equal to 225, which is negative kilojoule. So from first law of thermodynamics, Q is equal to W plus du, and Q given 0, work done is equal to minus du, as work is negative, so minus W is equal to du, which is equal to W given minus 225 is equal to du is equal to mcv T2 minus T1. So given a mass is 1 kg, cv is 0.75, and T2 we have to found, and T1 is 300. So from the equation we can get T2 is equal to, we'll have to solve writing. So minus 225 is equal to 0.75 into T2 minus 300. So it is equal to 0.75 T2 minus 225. This is minus plus. So 225 is equal to 450 is equal to 3 by 4 T2. So T2 is equal to 4 by 3 into 450. Is equal to 600 Kelvin, 600 Kelvin. So at constant volume from ideal gas, PV is equal to RT. So volume is constant, pressure is directly proportional to temperature. P1 by P2 is equal to T1 by T2. Given T1 is 300, T2 is 600, P1 is 1 bar, and we have to P2. 300 is double 2 times of temperature T2, that means 600. So this pressure is 2 times, that means 2 bar. So the final pressure of the bar is 2 bar, and B is the correct answer. That's all for today, and the remaining 1 mark question will solve in the next class. So thank you.